Welcome back, everybody. We are continuing with chapter 2. Today we're going to talk mostly about lines and graphing lines as well. We're going to start with the slope of a line. This formula is all over this paper, actually. It's referred to as the rise over the run, or the change in the y direction divided by the change in the x direction. And if x is any point, and x comma y is any point, we can replace one of them. And we end up with this. This is called point slope form. There's a way to avoid point slope form, but we're going to use it for this class. And here is slope intercept form. So I've sort of derived where these formulas are coming from as we're doing this. And slope intercept form is this one here. Is important because it tells us where the slope is and what the y-intercept is, and we're going to use that when we want to graph. We have a couple of other forms. We have the general form here, where we get the whole thing equal to 0. But by the way that you know that an equation is a straight line is if x and y are both raised to the first power only. If they're raised to anything else, second power or square root or something like that, we no longer have a straight line. And so here are the three general forms here. I'm sorry, general form, slope intercept form, and point slope form. You'll use point slope form when you know the slope already and you have a point that's on there. Then you can just dump all that in there and solve for y. Slope intercept form is if you have the slope and the y-intercept, then you would already do that. Anyway, let's do some practice. So we'll start with number 1. We're going to find the slope that contains these two. Now, I want to make it clear, you get to pick which one is your first point, which one's your second point. Usually students make this their, let me write that in real quick. They make this their x sub 1, y sub 1, x sub 2, y sub 2. But you don't have to. You could have this one with the 2's and this one with the 1's. It will make no difference in the end. So here we have 7 minus 4. And anytime you have a formula that has a subtract in it, you got to be really careful of the minus thing. And that will affect us here for this one. And here we have 0 minus -5. So there's that double negative there. So we have 3 over 5. Positive 3 over 5. Number 2, graph the line containing this point with this slope. So we are here, 1, 2, 1, 2, 3, 4. So we're going to start with the point 2, 4. And from there, I'm going to go down 2, and to the left 3, 1, 2, to the right 3, pardon me. So from there, I'm going to go down 2, 1, 2, and to the right 3. So we end up with this line here. So there's our graph for number 2. Number 3 has several parts. So we're going to write the equation of the line. We're going to do this. I'm going to do this over here. So 3, and then part 1 has a slope 3/4 and contains this point. So I'm going to do this. And I'm going to replace x sub 1 with the -2, y sub 1 with the 4, and the m with the 3/4. And we're going to finish in slope intercept form is the hope. So y, and again, with the minuses here, we've got to be careful of a double negative. We are here. Y minus 4 equals 3/4 x minus -2. So essentially plus 2. Over here. Oh, I didn't distribute the 3/4. So let's go here. Y is 4. Let's do that first. So 3/4 times x is 3/4 x. And here, remember that's plus 2. So it's going to be plus 6/4, which we can reduce. So this is going to be y equals 3/4. This is a good example of me skipping steps and not quite doing that right. I'm going to add the 4 to the other side. That's plus 3/2 plus 4, 8, 9, 10, 11. So y equals 3/4 x plus 11/2. There we are. Part 2 contains these points. So what we're going to do is we're going to find the slope. So let's do part 2. And we have the point. So that's going to be m equals -4 minus 2 over 3 minus 4. And it looks like it's going to be -6 over -1, which is just 6. I could use point slope form again. I could use y equals mx plus b and then solve for b. So, and I get to pick which point. I'll do this one. 2 equals 6 times 4 plus b is 24. So it was at -22. So we end up with y equals 6x minus 22. Part 3 gives an x-intercept of 3 and y-intercept of -2. So let's partition this off. All right, so for part 3, we have the point 3, 0. And they give us b, right? Y-intercept is -2, so 0, -2. So all I need really is the slope. Equals -2 minus 0 over 0 minus 3. That's going to be a positive 2/3, it looks like. So y equals 2/3 x minus 2. This is my b, this is my y-intercept. And for part 4, a vertical line is going to mean x equals a specific number. And in this case, x can only equal 5. That's literally it. If it was a horizontal line, then it would be y equals -1. All right. Number 4, find the slope and the y-intercept of this line here. I'm going to go ahead and subtract a 4x. So -6y equals -4x minus 3. Divide through by -6. 2/3 x, positive, yep, and then plus 1/2 looks like. Number 5, find the intercepts and graph the line. So the x-intercept, again, that's when y equals 0. So when y equals 0, do you see I'm going to get -2x equals 4 and divide by -2. So x-intercept is going to be -2, 0. Y-intercept, that's when x equals 0. So when x equals 0, we get y equals 4. And then to graph this, we get the one space here. 1, 2, 3, 4, 1, 2. Point here, straight edge. All right. Moving on to the next page. Part 2. So something about parallel lines. Parallel lines have equal slopes. So for parallel lines, m sub 1 equals m sub 2. They're rising and running at the same rate, is the idea. Perpendicular lines, m1 is equal to negative 1 over m sub 2. So they're what we call negative reciprocals of one another. So for part A here, yeah, we're just building the equation. So part A. 3x plus 2y equals 8. First, I need to find the slope. So I'm going to put it in a slope-intercept form. Divide by 2. So m in this case is negative 3/2. So a parallel slope will also be negative 3/2. And we're going through the point 1, negative 3. I'm going to use slope-intercept form again. So negative 3 equals negative 3/2 times 1 plus b. And we add the 3/2 to the other side. And get the scratch over here. So negative 3 plus 3/2, negative 6 over 2 plus 3/2 is a positive 3/2. Negative 3/2, right? The 6 is bigger. So this means that b is negative 3/2. So the equation of the line that's parallel to this one, but this one, it's the same. Negative 3/2 x minus 3/2. Part B, find the equation of the line that is perpendicular to this line and goes through this point. So let's subtract the 5x both sides. We'll put this in a slope-intercept form so we can clearly see what the slope is. Divide by negative 3. So if the slope is 5 over 3, then the perpendicular slope is negative 3 over 5. So it's always the opposite sign and you flip it. And we're going through the point 6, 2. We'll use slope-intercept form again. 2 equals negative 3/5 times x, which is 6, plus b. So 2 equals negative 18 over 5 plus b. So b is 2 plus 18 over 5, which is 10 over 5 plus 18 over 5, which is 28 over 5. So our perpendicular line is negative 3 over 5 x plus 28 over 5. Yay, not so bad. Let's talk about slope of the line. Slope, they say which way how the line is slanted. I would say that it's more about the direction that the line is going. And here's several ways that slope is often written. It's a vertical change divided by the horizontal change, change of y over change of x, rise over run. These all mean the same thing for us. And there are 4 ways that we can view slope. When we have a vertical line, that means something really bad is happening. That's really not good. This slope is undefined, actually. Meaning it's so bizarre that we don't even have a definition for it. Horizontal lines have a slope equal to 0. Now, for this line, as x is getting bigger, y is also getting bigger. This is a positive slope when it's going in this direction, and when it's going in that direction, that is a negative slope. So these are all the various directions that we could go. Here's the slope again. So graphing linear equations, we've already done that. The solution said, okay, so here we have a y-intercept of 3, an x-intercept of 4, and here's our slope intercept form. I see what happened here. There's supposed to be a space there. Y equals mx plus b. M is called the slope. B is called the y-intercept. And here's all these names. It's not all that important. Standard form is this here. This is really nice when we're doing systems of equations. General form just means it's equal to 0. Vertical line, x equals a number. Horizontal line, y equals a number. So vertical is this way, horizontal is this way. Of course, slope intercept form and point slope form. In parallel lines, or perpendicular lines, we talk about this. Parallel, same slope, perpendicular, negative reciprocals of one another. Part 3. Let's graph these lines. So part A is already in slope intercept form. So I'm just going to jump right to the graph. So we're going to start here at 1. We're going to rise 1 and run 3 in the positive direction. Ideally, you have the line go all the way through both axes, if possible. That's often not even possible. All right, for part B, I'm going to write this out a little bit. I'm going to put it into slope intercept form. I'll go here for B. I'm going to subtract the 2x here. Divide by 3. 2/3 plus 8/3. That is not ideal. So let's do this instead. Let's find the intercepts. We could graph it like this, but I want to keep it simple. And we are going to end up with fractions, whether we like it or not. I'm going to push that up a little bit. And let's go down here. 2x plus 3y equals 8. For the x-intercept, that's when y equals 0. So when y equals 0, I get 2x equals 8. This means x equals 4. Put that down. 4. For the y-intercept, when x equals 0. When x equals 0, can you see that y is going to be 8/3? And that 8/3, if you divide that out, so this becomes 2 2/3 on the y-axis. So here's 2 2/3 of the way is about there. Let's draw in our straight line. So we can deal with fractions. They don't have to all be nice, pretty whole numbers, which is nice. All right, so here we have some applications. A car rental company charges a base fee of $45 plus 50 cents per mile. Write a cost function where x is the number of miles driven. So that means C of x is going to be 0.5x plus 45. And here you can see that this has a slope of 1/2. Has a slope of 1/2. And y-intercept of 45. We are not going to graph that. All right, so let's build the equations of these lines. This has a y-intercept, so this is going to be -2. Let's see what the slope is. So I can go 1, 2 over up, and then 1, 2, 3. So 2/3 x minus 2. This one has a y-intercept of 0. So the plus part at the end of y equals mx plus b, b is 0, so it's just going to be missing. So what we do need is the slope. So it looks like this slope goes up 2 and back 1, or down 2 and to the right 1. Either way, the slope is definitely negative. So y is going to equal negative 2x. I'm not sure if your teacher would mark you off if you put plus 0. At college algebra level, I wouldn't want to see that. Here we have a horizontal line, and it's going through 3. So this is just y equals 3. That's it. And for our last one here, we definitely have a negative slope here. So it looks like the y-intercept is at 1. And let's see how far up we're going. 1, 2, 3 up. And 1, 2, 3, 4 back. So negative 3/4 x plus 1. Not too bad. A lot of stuff we've already gone through.